In our lesson today, we're going to have more practice simplifying expressions, and we're going to really incorporate fractions and decimals into our work today. And so what we're going to do is just a quick review about adding and subtracting with fractions and mixed numbers. And so we're going to look at this box right here. Okay, remember that if you're adding or subtracting with fractions, that you need to have common denominators. All right, and so in these examples, they already have common denominators. If I have 2/5 plus 4/5, since they're the same sign, I'm just going to add them together, which would give me 6/5. Add the numerators, keep the denominator. And then because the numerator is bigger, you would make that a mixed number. 5 goes into 6 once, with 1/5 left over. Okay, if it's 2 1/3 plus 1/3, okay, in this example, again, I could keep my whole number, the 2. All right, and then I could add my fractions together. 1/3 plus 1/3 is 2/3. The other way that you could do this would be to make your mixed number a fraction. 3 times 2 is 6, 6 plus 1 is 7, so that would be 7/3 plus 1/3, which would give me 8/3. And now 3 goes into 8 twice. 3 times 2 is 6, so there are 2/3 left over. Okay, either method will work there. Okay, I want to do an additional method that isn't in here. I want to show when the denominators are different, like if I did 3/4 plus 2/3. The first thing that you would have to do here is get common denominators. Okay, so if I have fourths and thirds, my common denominator would be a 12, so I'm going to rewrite each fraction so that the denominator is a 12. 4 times 3 is 12, so 3 times 3 is 9. 3 times 4 is 12, so 2 times 4 is 8. And now I would add these together. 9/12 plus 8/12 is 17/12. And now 12 goes into 17 once, with 5/12 left over. So if you add 3/4 with 2/3, you get an answer of 1 and 5/12. Okay, and so that's basically what we were doing back in the first topic. Okay, we were adding and subtracting with fractions. In this example now, notice that it looks very similar to what we were doing before, except now I've added a variable in there. Okay, if you're adding and subtracting terms with fractional coefficients, you need to have the same variable and exponent. Okay, these are the same variable with the same exponent. Remember, there's an invisible 1 above each of those x's. Same thing down here. When they have the same variable and exponent, you can combine them. And again, if I'm working with fractions, I need to make sure that I have common denominators. So, like over here, 2/5 plus 4/5 was 6/5. 2/5 x plus 4/5 x is going to equal 6/5 x. And now all I'm going to do is rewrite that again as a mixed number. 5 goes into 6 once, with 1/5 left over, so this is going to be 1/5 x. Taking a look at this example, again, very similarly, 2 1/3 plus 1/3 was 2 2/3. So 2 1/3 x plus 1/3 x is going to be 2 2/3 x. If you were to do that with this example down here, so if I had 3/4 x plus 2/3 x, well, again, you're going to want to get those common denominators. So I'm going to have 9/12 x plus 8/12 x, which would equal, as we said over here, 17/12 x. And then as a mixed number, that was 1 and 5/12. So this would be 1 and 5/12 x. So it's just like what we were doing before. All right, get those common denominators. And then again, remember that they have to have the same variable and exponent in order to be able to combine them. Incorporate some negatives into the mix. All right, so pay attention to the signs of the terms. All right, do we have positives? Do we have negatives? Do we have both? Because that's going to influence what we need to do when we are combining those similar terms. Okay, so taking a look at the first example here, I have negative 2/5 x plus 4/5 x plus 4 minus 5. Okay, and as we did last time, I like to have my variable terms in front and my constants at the end, so this one is already organized the way I like it. I've got my two variable terms together, I've got my two constants together, and these are similar terms, same variable and exponent, so I can combine these. And so I'm going to look at their signs first, and I see I've got a negative and I've got a positive. Those are different signs. When we have different signs, we have to subtract the absolute values, okay? So if I have 4/5 x minus 2/5 x, 4/5 minus 2/5 would be 2/5. So I'm going to combine those first. That's going to give me 2/5 x. And I'm just going to bring down my constants, plus 4 minus 5. Okay? Constants and variable terms can't be combined, but constants and constants can be combined, so I'm going to combine those. And again, pay attention to their signs. This is a positive 4, this is a negative 5. They're different signs, so we have to subtract. 5 minus 4 is 1. The negative number has the greater absolute value, so this would be negative 1. So I'm going to bring down my 2/5 x, and then since this was equal to negative 1, I'm going to write minus 1. And now I have a variable term and a constant. You cannot combine those. That's as simplified as that expression gets. Taking a look at the second example, I have negative 2 plus 3 1/5 y squared minus 2/5 y squared minus 3. I want to rearrange this with my variable terms in front, constants at the end. So I'm going to have, this is a positive 3 1/5 y squared, 3 1/5 y squared. This is a negative 2/5 y squared, so minus 2/5 y squared. And then this is a negative 2, so I'll write minus 2, and that's a negative 3, so I'll write minus 3. And there is my new expression, okay? So I'm going to start with my variable terms. Again, these are the same variable raised to the same exponent, so I can combine these. And the first thing I notice is that I've got a mixed number with a fraction. So I'm actually going to change this mixed number into a fraction first. 5 times 3 is 15, plus 1 is 16. So this is 16/5 y squared minus 2/5 y squared. So if you did 16/5 y squared, let me make that look more like a 6. 16/5 y squared minus 2/5 y squared. 16/5 minus 2/5 would be 14/5 y squared. Then I can bring down the minus 2 minus 3, minus 2 minus 3. Okay, and so I need to combine my constants. So I'm going to keep this 14/5 y squared, but I'm going to rewrite this fraction as a mixed number. 5 goes into 14 twice. 5 times 2 is 10, so there would be still 4/5 left over. So that's the same as 2 4/5 y squared. And now when I combine my constants, if you notice here, these are both negative. These are the same signs. When they're the same signs, you need to add. Negative 2 and negative 3 would make negative 5, so I'm going to write minus 5. And variable terms can't combine with constants, and so that is my simplified expression. 2 4/5 y squared minus 5. Looking at the last example, I have 3/4 x to the third plus 2 3/4 x to the third minus x squared plus 3x squared. All right, they all have the same variable x, but they don't all have the same exponent. You can only combine them when they have the same variable and exponent. So I can combine my x cubed terms together, and I can combine my x squared terms together. All right, I actually don't have to rearrange this because I've got my x cubes in front, my x squareds at the end. So what I'm going to do is go ahead and see if I can come up with my answer. So I'm going to first combine my x cubed terms. So I'm going to have 3/4 x cubed. And I'm going to add, I'm going to make this a fraction. 4 times 2 is 8. 8 plus 3 is 11. So that's 11/4 x cubed. So if I were to add these together, 3/4 plus 11/4 is 14/4 x cubed. Now I'm going to bring down minus x squared plus 3x squared. Okay, well, what I'm going to do with my 14/4 is make that a mixed number. 4 goes into 14 3 times. 3 times 4 is 12, so there are still 2/4 left over. So that's 3 2/4 x cubed. And now I'm going to combine my x squared terms. This is a negative, this is a positive, they're different signs. And remember, when the variable is all by itself here, there's an invisible 1. So that's really a negative 1 and a positive 3. So since these are different signs, we'll subtract. 3 minus 1 is 2. The positive number has the bigger absolute value, so I'm going to have plus 2x squared. Okay, and at this point you might be thinking that you're done, but remember, we are simplifying expressions, and if I look at this mixed number, that's actually not in simplest form. 2/4, that fraction simplifies down to a half. So this is going to be 3 1/2 x cubed plus 2x squared. X cubes and x squares are not similar terms, so that is now in its simplest form. Okay, so always check to make sure that your fractions are in simplest form. Pay attention to the signs. That's going to help you figure out if you should add or if you should subtract.